Engineering for durability remains a priority for heavy equipment manufacturers. And yet, over-designing is not an option. On the contrary, it may blunt your competitive edge in an industry where equipment productivity, operability, safety, comfort, energy efficiency, and cost of ownership matter. So how do you balance all of your customers' requirements while still offering superior strength and durability? An industry-proven process couples test and simulation to address this dilemma. It helps to resolve conflicting issues earlier on and at a lower cost. It starts and ends with accurate data. First, you need to acquire real operational loads in the most extreme conditions. You want to connect the ruggedized data acquisition system to the sensors and start capturing the real-world data that will serve as an input for virtual and physical validation. Rock it, shake it, splash it, drip it in mud. Your data is always safe and ready to use. No test reruns needed. A set of embedded methods, such as automated data cleanup and on-the-spot analysis and reporting, allows for in-the-field validation. You can optimize your testing schedule right there, right away. Rely on load data mining services to define realistic and customer-correlated durability targets and procedures. This allows you to design accelerated test procedures that account for geographic differences and to adapt product requirements considering local conditions and vehicle loading. Fatigue analysis is an important step in the process. It supports virtual product validation. A simulation-based durability analysis helps to identify weak spots within the structural design in order to optimize it. The analysis follows a workflow that starts with pre-processing via multi-body simulation to obtain realistic loads and ends with advanced durability studies. All steps are integrated into one engineering platform. To maximize uptime and minimize maintenance costs, you need to prevent physical component failure. Don't limit yourself to determining the average remaining lifetime based on statistics. Instead, quantify the remaining useful lifetime of components, subsystems, and machines under their specific real-use conditions. By cascading the loads predicted on full system level down to the subsystems and components, you can precisely assess critical stresses and lifetime behavior. Simcenter experts can also help you target preventive actions to deal with a predicted failure by connecting real data with system simulation or CAE 3D simulation in a digital twin. Lab and field testing complete your engineering process. Accelerated testing shortens development and testing time and drastically increases the return on investment of expensive testing facilities. You can either test a single component from your structure, or you can test the whole machine with realistic test scenarios in repeatable environments. With Simcenter, you rely on a trusted end-to-end solution, encompassing all steps of durability engineering. Seek a true hybrid way of engineering and offer your heavy equipment superior structural integrity and durability. Tough. Tougher. The toughest. Unleash the powers of an industry-proven durability engineering process on your heavy equipment.